We can add or subtract polynomials in much the same way that we add or subtract real numbers. We simply add or subtract like or similar terms. Like or similar terms are terms with the same variables raised to the same powers. Here are some examples for addition. To add horizontally, we group together like terms. When adding vertically, we place like terms in the same column. Do you recall the rule for adding numbers algebraically?
Yes. If the two numbers have like signs, we get the sum of their absolute values and affix the common sign.
And what if they have unlike signs?
We subtract their absolute values and affix the sign of the greater absolute value to the difference.
Good. How about the rule for subtraction of signed numbers?
Easy. We change the sign of the number to be subtracted, that is the subtrahend, and proceed as in algebraic addition.
Here are some examples of subtraction of polynomials. What property of multiplication is evident here, Carla?
Commutative property?
Nope. What do you think, Bea?
Distributive property, like we're distributing the operation to the terms of the binomial.
But do we also do that when we multiply terms vertically, Mia?
Yes, we do.
How about when we have more than one term in the multiplier?
Yes. How?
Well, we multiply by one term at a time, then add the partial products. Done horizontally, we get the same results. There's a shorter and faster way to do this. Do you recall the FOIL method? FOIL is the acronym for getting the product of two binomials horizontally. F stands for the product of the first terms. O stands for the product of the outer terms. I stands for the product of the inner terms. L stands for the product of the last terms. Now see if you can get this product orally using the FOIL method.
The product is 6x squared plus 11x plus 3.
Okay, what happens when the two binomials to be multiplied are the same? For example, quantity 2x plus 3 multiplied by quantity 2x plus 3. This is equivalent to squaring the binomial quantity 2x plus 3. And if we apply the FOIL method, we notice something special. The resulting trinomial has special characteristics. These are: number 1, the first and third terms of the trinomial are perfect squares. They are the squares of two terms of the binomial being squared. Number 2, the middle term is twice the product of the first and second terms of the binomial. Thus, to square a binomial, we simply A. Square the first term, B. Double the product of the first and second terms, then C. Square the second term. Try it on this one. Use these aids. This means square the term. This means multiply and double. The result is a perfect trinomial square. Can you do this fast without using pencil and paper?
100x squared plus 140x plus 49.
16x squared minus 24x plus 9.
Do you notice another special characteristic of the square of a binomial? That is, about the signs of the resulting trinomial square?
The first and third terms of the trinomial are always positive.
That's good. Notice too that the sign of the middle term follows the sign between the terms of the binomial being squared. Now here's an application of the square of a binomial. What is the area of a square whose side is quantity 3y plus 4?
Area equals side times side.
Good. A is equal to quantity 3y plus 4 times quantity 3y plus 4 is equal to quantity 3y plus 4 squared and is equal to 9y squared plus 24y plus 16. From the diagram, we see the smaller square whose side is 3y. Its area 3y times 3y is equal to 9y squared. The area of the smallest square is 4 times 4 equals 16. The area of each rectangle is 4 times 3y equals 12y. Since there are two such rectangles, their combined area is 24y. Thus, the area of the large square whose side is 3y plus 4 is quantity 3y plus 4 squared equal to 9y squared plus 24y plus 16. Now, how can we use this in mental arithmetic? Suppose we want to get 31 squared mentally. We can think of 31 as quantity 30 plus 1. Verify your answers on a calculator. Are you convinced that it works?
Yes.
But you can still do the squaring faster. Start from the rightmost digit. 4 squared equals 16. We write 6 and carry 1. Quantity 4 times 2 doubled equals 16, plus the 1 carried equals 17. Write down 7, carry 1. 2 times 2 equals 4, plus the 1 we carried over equals 5. Therefore, 24 squared equals 576. Can you do this mentally? Now try it with bigger numbers. Because algebra is a language, do you see how knowledge of algebra makes things easy?
Yes, I never thought I could solve more difficult equations mentally.
Okay, you all did well. We've covered a lot.
Yes, we did. We studied algebraic expressions and defined a polynomial in X.
We also wrote polynomials in standard form and practiced operating on polynomials.
We also squared numbers mentally.